7.4 Properties of Special Parallelograms. So today we're going to talk about certain special types of parallelograms. And let's see, your essential question, what are the properties of and here they are. Here's the special types of parallelograms. Rectangles is one of them. Rhombuses, that's another type. And squares. So those are the three types of special parallelograms. All right, so what you're going to do is you're going to look through pages 388 through 391 to find properties of the following parallelograms. You're going to list the properties next to each bullet, draw a picture of each, mark all congruent sides, angles, and diagonals, as well as any right angles. Then complete the Venn diagram below. So if I were you, I'd pause the video now, and then you can try and fill out all these bullet points for the rhombus, the rectangles, and the squares. And then you can come back to the video. Okay, now that you've done all that. So, for a rhombus, what's important to know is that you have 4 congruent sides. So it's kind of like a square, but you don't necessarily have 4 right angles. So a rhombus is like a square, but it's been pushed over a little, right? It doesn't have these 90-degree angles, but all 4 sides are congruent. The diagonals are perpendicular. So if you draw your diagonals, they're going to form 4 90-degree angles or 4 right angles. And the diagonals bisect a pair of opposite angles. Diagonals bisect a pair of opposite angles. So what I mean by that, for example, this diagonal here is cutting these 2 angles in half. Well, remember, it's a parallelogram still, so opposite angles are congruent. So when you bisect it now, this part of that angle is congruent to this part, and those 2 angles are congruent to these 2 angles. And the same goes with the other angles, right? These 2 angles are also congruent, so we're going to bisect those with the diagonal. So I'll make 2 arcs on those. How about that? And those ones are going to be congruent to these ones. All right, so that's a rhombus. Let's see. So a rhombus is one of your special parallelograms, and you need to know all these properties. The next one is a rectangle. You should be very familiar with a rectangle. So a rectangle is a parallelogram, but the parallelogram has 4 right angles. So let's see. So it's like a parallelogram that's standing up straight. So it's got all the angles are 90-degree angles. And therefore the diagonals are congruent. And remember, in a parallelogram, the diagonals bisect each other. So this truly is the midpoint here. And so that means that every single part of these diagonals are going to be congruent. So from the midpoint to each angle, right, since it's bisected and since they're congruent, all the parts are going to be congruent. Okay, and then you're also very familiar with the square, and the cool thing about a square is the square is basically a rhombus and a rectangle. Let me highlight rectangle because that's also one of our special parallelograms. So a square is when you take a rhombus and a rectangle and you combine them together. So you got the 4 congruent sides with the 4 right angles. Right? You got the diagonals being perpendicular, the diagonals congruent, and the diagonals bisecting opposite angles. All right, so a square is a rhombus and a rectangle. So you have the 4 congruent sides. You have the 4 right angles. And then the diagonals are all of the above. So the diagonals, wait, I have to be able to spell it. Diagonals. Well, they are perpendicular. They're congruent. And they let me put and in there. And bisect opposite angles. Okay, so that's the square. So there's your 3 special types of parallelograms, and you need to know all the different properties of these special types of parallelograms. And basically, if you know the rhombus properties and the rectangle properties, you just combine those to get the square properties. So a Venn diagram basically has like 2 separate sections where things are not alike, and then they overlap where things are alike. So over here, notice I have these shapes that have all congruent sides. And then over here, I have these shapes where all the angles are congruent. They're all 90 degrees. So over here, all congruent sides, that's a rhombus. Over here, for congruent 90-degree angles, that's a rectangle. And then you marry those two, and you end up with, well, 4 congruent angles that are 90 degrees and 4 congruent sides, that's a square. So that's the area where they're overlapping, where they got stuff in common. All right, let's apply some of these properties. So we have a rectangle ABCD. Decide whether the statement is always or sometimes true and explain your reasoning. So I think to help me with this, I'm going to draw myself a picture of a rectangle. It doesn't matter where you start. So how about I'll go clockwise A, B, C, D. Counterclockwise. Sorry, I did not go clockwise. Counterclockwise, right? This direction. Clockwise would be that way. For any rectangle ABCD, we're going to decide whether the statement is always or sometimes true. Okay, so is AB equal to BC? Are these 2 lengths the same? So is AB equal to BC? So if we have a rectangle, well, a rectangle didn't say anything about all sides being congruent. It is a parallelogram, so opposite sides are congruent. But it would also have to be a square in order for all, or it'd have to be a rhombus, I would say, which would then make it a square, for all sides to be congruent. So I think that this could be sometimes, if in fact this rectangle is also a square, or if this rectangle is also a rhombus, that would make it a square. Okay? So you can say sometimes, if ABCD is a square, then all sides would be congruent. I'll just put congruent. Oops, sometimes. There we go. Now, is AB equal to CD? Well, as we said, a rectangle is also a parallelogram, and in a parallelogram, opposite sides are always congruent. So I would say always opposite sides are always congruent, or I'll just say are congruent, since rectangles are parallelograms. And that's a property of parallelograms. Example 2, we're going to classify the special quadrilateral and explain your reasoning. Okay, so first of all, I know that both pairs of opposite sides are parallel. So right away, if I know that both pairs of opposite sides are parallelogram, I know that this is a parallelogram. Did I say that right? If I know that both pairs of opposite sides are parallel, then it is a parallelogram. Okay. Now the other thing that I know is that consecutive sides are congruent. Okay, well, if it's a parallelogram, opposite sides are going to be congruent, right? So this side would be this, congruent to that side, and this side would be congruent to that side. So then all sides are congruent. So we can say that this is going to be a rhombus because we have all sides being congruent. Okay, so we know that it's a parallelogram because both pairs of opposite sides are parallel. Okay, and then we have these adjacent sides, or these consecutive sides, also being congruent. So I'll say since adjacent sides are congruent, all sides are congruent. Because it's a parallelogram. And I'm going to put, therefore, it's a rhombus, which is a special type of parallelogram. So this is the conclusion, but we had to explain our reasoning. So we started with the fact that it's a parallelogram because both pairs of opposite sides are parallel. So we knew that to begin with, and then we could just apply the properties of parallelograms to the fact that we knew that these two sides were going to be congruent, opposite sides have to be congruent, therefore we know it's a rhombus because all sides are congruent. All right, example 3, we're going to find angle measures in a rhombus. So we're going to find the measure of angle ABC, so that's this angle right here, and ACB, which is this angle right here. And we know that it's a rhombus. Okay, so that's key. Okay, so let's think about what do we know about rhombus angles. So we'll go back to the front here. We know that diagonals bisect a pair of opposite angles. Okay, so that tells me here that if this angle is 61, then so is this angle. But this angles 3 and angle 2 add up to be exactly the same as this angle C over here. So that means that angle 2 and angle 3 both have to be 61 degrees. So this one's also going to be, those are both also going to be 61 degrees. Okay, well, because it's a parallelogram, let's see, do we have to explain now? Okay, so because it's a parallelogram, I know that consecutive angles, these two angles here, remember it's a parallelogram, so this side's parallel to this side, we got a transversal happening, so what needs to be true about this big angle B and this big angle C? Well, they need to be supplementary, right? So if this entire angle right here is 128 degrees for angle C, well, angle B is basically 180 minus that. So what is that? 52 degrees? So angle B is going to be 52 degrees. So then what does that tell me about each of these two angles here? Well, let's see here. So 52 degrees divided by 2 is 26. So each of these angles here are 26 degrees. And the same would be true down here, right? So angle 4 here would also be 26 degrees, and so would this angle here. All right, I'm getting off course here. So what is it asking me to do? Find the measure of angle ABC. Oh, well, that was just 52 degrees. And then the measure of angle ACB. So let's see, ACB was going to be 61 degrees. Okay, example 5. Finding diagonal lengths in a rectangle. So in this rectangle, AC, the length of AC, is 7x minus 15. And the length of BD, the other diagonal, is 2x plus 25. Find the lengths of the diagonals. Okay, well, we know that it's a rectangle. Now, what do we know about diagonals in a rectangle? Diagonals are congruent. So I've been given expressions for the length of each diagonal. If they're congruent, I can set them equal to each other. I have to find the length of each diagonal, which means the first thing I need to do is solve for x. So I'll subtract 2x from both sides, and at the same time I'll add 15 to both sides. So I end up with 5x equals 40. Divide both sides by 5, so x equals 8. I have not answered the question, so I need to find the lengths of the diagonals. So let's start with AC. So AC will be, well, that's 7, and I know x is 8 minus 15. So 56 minus 15 is going to be 41. Now again, what do we know about the lengths of these diagonals? Diagonals are congruent. So what does that tell me about the length of BD? Well, the length of BD is also going to be 41. Okay, let's see what's next. Example 6. Identifying a parallelogram in the coordinate plane. So you're going to decide whether parallelogram ABCD with these following vertices is a rectangle, rhombus, or a square. Give all names that apply. Looks like they want us to graph it because we're given a coordinate plane, so we'll go ahead and we'll do that. So -2, 3. B is 2, 2. Oops, that was not 2. Sorry about that. Hopefully you're looking at what I'm doing and saying, what are you doing? There we go, that's 2. C is 1, -2. And D is -3, -1. Okay, I think I should use a ruler for this one. So we know it's a parallelogram. We just need to figure out what kind of special parallelogram it is. And we're going to use the properties. So let's see what we got here. So 2 things. It would be a rhombus if, for example, the diagonals are perpendicular. And it'll be a rectangle if the diagonals are congruent. And then if both of those things are true, then it would be a square. So I think what we can do is we can really narrow this down by testing the diagonals. Okay, so that's what I'm going to do here. Put a little star. We're going to test diagonals. All right, so first of all, are the diagonals perpendicular? Well, how would I know that? The way I could figure that out is by looking at the slopes, right? Perpendicular lines or segments have opposite reciprocal slopes. So let's look at the slopes of the two diagonals. Okay, so one of my diagonals is DB. So let's find the slope of diagonal DB. Well, to go from D to B, it looks like I go up 1, 2, 3, and over 1, 2, 3, 4, 5. So that's 3/5. You can also use the slope formula, but since it's already graphed, you might as well count. And then my other slope is AC. So let's also find the slope of segment AC. So to go from A to C, it looks like I go down 1, 2, 3, 4, 5. So down 5. And then from there I go over 1, 2, 3. So over 3. So what can you tell me about these two slopes? Well, the slopes are opposite reciprocals, so the diagonals are in fact perpendicular. So we know it's a rhombus. Okay, that's part 1. So part 2, let's see. So we got the diagonals being perpendicular. Now we need to know if the diagonals are congruent. So if the diagonals are congruent, then we'll know that it's also a rectangle, and therefore it'll also be a square. All right, so let's do that. So our second question here is, are the diagonals congruent? All right, well, let's find the length of each diagonal. So I'll start with DB. I'm going to do the distance formula. Doesn't matter which one you choose, but I'll make the first one x1, y1. So D is my x1, y1. B is my x2, y2. Okay, so I'm going to do the change in the x's squared plus the change in the y squared. So x2 is 2 minus x1, negative 3. Square that, plus, and then y2 is 2 minus y1, which is negative 1, and square that. So let's see. This will be 5 squared plus, and then this will be 3 squared, or 25 plus 9, square root of 34. Now, 34, the only factors of 34 are 2 and 17. So that can't be simplified. So we'll just leave it as a square root of 34. Okay, and then we'll do the same thing for, let's see, AC. So the length of AC, so again, you can just call A x1, y1, and C x2, y2. And then you're just going to find the change in the x's. So 1 minus negative 2, square that, plus, and then we'll do negative 2 minus 3 and square that. Well, minus a negative gives us positive, so that's 3 squared. And then this is negative 5 squared, which once again gives us 25 plus 9, or the square root of 34. Okay, so we know that the diagonals are congruent. So that means it's a rectangle. Now, if it's a rhombus and a rectangle, what actually is it? Well, if it's got all the properties of being a rhombus, all the properties of being a rectangle, then it's also going to be, according to our Venn diagram, a square, right? Or what we've defined it as. So let's see. I'm just going to write it over here. ABCD is a square. Since it's both a rhombus and rectangle. And I'd have to prove it, so you got to go through the steps here to prove that it is in fact a square.